Okay, so we are into the second part of 4.1. We're going to get into arc length and some coterminal angles. That is what we're doing for today. So, purpose: to determine arc lengths from angles, and we're going to do that in the reverse. Given the angle, find the arc length. Not too bad. And we're going to determine what coterminal angles are, what are they in specific situations, and that's about it. So remember from last class, 2 pi equals 360 degrees. This is one complete rotation. So from this we get angles that are used frequently and are worth memorizing. The and is a little bit cut off there, but oh well. So from this, 2 pi equals 360. That's good to know. Pi equals 180. Pi over 2 is 90 degrees, pi over 3 is 60, pi over 4 45, pi over 6 is 30. So these are angles that are going to be used all the time. It is very handy to know these, and when you see pi over 2, pi over 3, pi over 4, pi over 6, or pi and 2 pi, know that that means something special. It's a special case, and it is going to be important. So just keep that in mind as you are, whenever you see angles, these ones are important. Arc length. So the A here in this drawing is the arc length. I talked a little bit about it when I showed radians. If the arc length is equal to r, that the angle that gives you that is your radian. It's the definition of radian. If you don't remember that, go back to the last video. So here is a circle. You've got the radius, you've got the angle, and you've got the arc length. From that, we get this equation. A equals r theta. The important thing for this is theta, which is the angle, must be in radians. If it's in degrees, this is not going to work. Remember I told you you have to get to know radians because some cases that is what's going to be used. And here's one of them. Let's determine the arc length if the radius is 4 and the angle is 5 radians. Again, sometimes you'll see the capital R, sometimes you won't. So arc length equals r theta. The radius is 4, theta is 5, times them, you get 20 centimeters. Not too bad. Let's do it 9 millimeters, and theta equals 70 degrees. So here's our equation again. But notice we need to change the angle into radians. So do this first, times it by pi over 180. This equals 7 pi over 18. Now we can plug that into our equation. So the radius times the angle in radians. This gives us 7 over 2 pi millimeters, or 11 millimeters. 11 is rounded, but for something like this, it doesn't make sense to give an exact answer. The rounded one is much better. So now let's do the opposite. Let's determine the angle given the arc length and the radius. Same equation, plug in the numbers, solve for theta, and it asks for it in degrees. So times it by 180 over pi, and there's your degrees. Pretty straightforward for that. Coterminal angles. So coterminal angles are angles that have the same terminal arm. Remember, the terminal arm is when we're looking at an angle in standard position. You've got the initial arm, the incident arm is on the positive x-axis, and then the terminal arm is the one that rotates. So for instance here, if I'm looking at 90 degrees, so the terminal arm is up at 90 degrees. Both of these, the 90 degrees and the negative 270, are coterminal. They have the same terminal arm at 90 degrees. So therefore these two are coterminal. Now be careful with this, because this does not mean that 90 degrees is equal to negative 270 degrees. These are not the same. They're coterminal, but they're not the same. So just be aware of that. Just because they're coterminal doesn't mean that they're the same. determine several coterminal angles of 50 degrees. So here is 50 degrees. Now in order to get to the next coterminal angle, I need to rotate another 360 degrees, as indicated there in the green line. And this gives us, since we did a full rotation, 410 degrees. I can do that again, rotate another 360 degrees, and I get a new angle. So notice all I need to do is add 360 degrees to continue getting new angles. So in general, take your theta plus 360 degrees times n, where n is just some integer. Positive 1, positive 7, negative 200, those are all integers, and each of that will give you a coterminal angle. Let's try this again, except now we're going to do it in radians. So looking at this, yes, I know it looks a little bit confusing at first. But first, what we've got from this is negative 4 pi over 3. So that's one of them we can do. If we add 2 pi from that, so notice the green line, we started at the terminal arm, rotated a positive full rotation, which is 2 pi. We got 2 pi over 3. Take that again, rotate another 2 pi, and we've got 8 pi over 3. So in general, theta equals 2 pi n. This looks the exact same as the other one, except instead of 360, now it's 2 pi. So that's your general equation for coterminal angles. So if I want to look at what are all the coterminal angles of negative 2.4 from 0 to 4 pi, so 2 complete rotations. Notice this is in radians. So I start with my angle and I subtract 2 pi. And I'm going to check this. Is this in the range? So is negative 8.68 in between 0 and 4 pi? Definitely not. Negative numbers are not between 0 and 4 pi. So then let's take negative 2.4 and add 2 pi. How about 3.88? Is that in between 0 and 4 pi? Yes. Add another 2 pi. Is that in between 0 and 4 pi? Yes. Add another one. Is this in between? No. So that is the process you're going to look at. So all the coterminal angles of negative 2.4 between 0 and 4 pi would be 3.88 and 10.17. Those are going to be the coterminal angles. So notice my strategy with this. I subtracted a full rotation until I got out of the range, which this one I was out of the range at the very beginning. So then add 2 pi to see until, you keep going until you get out of that range. Oh yeah, so this one's saying determine all of the coterminal angles. So not just the ones that are in a range, I want every single coterminal angle. So if I look at the one that was just before this, sorry, that's the same one. So if I'm looking at this, these are each coterminal angles of negative 2.4. But this is not every single coterminal angle. This is just 4 of them. So this question that I'm doing is saying I want every single one of them. Now the problem is you can keep adding 2 pi or subtracting 2 pi to get many, many, many coterminal angles. So how do I do the whole thing? It's using this equation. So remember, in general, theta plus 2 pi n, where n is a real integer, would give me a coterminal angle. So if I want all the coterminal angles of negative 2.4, I'm just going to put this. Negative 2.4 plus 2 pi n, where n is an integer. This gives me every single coterminal angle of negative 2.4. And that's my answer. So anytime you're looking for what are all of the coterminal angles, I need this general equation. So that's the end. That's like the conclusion to 4.1. So you've now seen everything for that. Yeah, so give those practice problems a try. Okay, so this lesson, I've got an extra special one for you guys, a random fact for this lesson. Did you know that when you shave your hair, it comes back fuller and thicker and darker? Yes, this is what actually happens. Those of you who are planning to grow out your beards, if you trim it, it comes back more full. That's just how it is. So if you want to get a fuller beard, you gotta trim it. That's how it works. So if you want that nice full beard, the one that goes down here, like I used to have one like that, you gotta trim it. That's the secret. So there you go, now you know.